Welcome to the Curious Calculator. In today's episode, we're going to be going over the following problem. Determine which of the following are relative extrema of the function f of x given the function f prime of x equals x minus 4 times x minus 7 squared times x minus 10 to the fifth. And we're given three options here. The first being x minus 4 is a relative maximum. The second, x equals 7 is a relative minimum. And the third, x equals 10 is a relative maximum. And so I'm going to be going over this problem in two different ways just to give you a couple options here, and you can end up doing whatever way you feel most comfortable with. And so to begin here, let's notice that we are not given the function f of x, but we're given its derivative f prime of x. And so what we need to do here to determine whether or where this function has relative maximums or relative minimums, we need to look at where the derivative of the function is changing signs from positive to negative or negative to positive. So we need to locate where that happens. And in order to do that, we first need to find the zeros of the function, and then we're going to create a sign chart where we label where the derivative of the function is 0, and then we're going to say where or in which of these intervals is the derivative of the function positive and where is it negative. So let's get started here, and I'm going to draw out a little line right here. And then on this line, I'm going to label where the derivative of the function is 0. And so the first one, that will occur when x equals 4, because this first factor here will go to 0. And so we can label, 4 right here. And then the next one will be when x equals 7. And so we can label 7 here, because 7 minus 7 will be 0 for this factor. And then the next one will occur when x equals 10 here. Okay, so now we need to find whether the derivative of the function is positive or negative in each of these intervals. So for the first interval here, I'm going to choose to plug in 0 to the derivative and evaluate it there. So let's go ahead and do that right here. I'm going to do f prime of 0 equals, and I'm not going to actually write out the numbers here. I'm just going to keep track of where we're positive and negative, and so we'll see how that goes here. So let's plug in the first one, 0. So we have 0 minus 4, which is going to be negative. And so I'm just going to write a negative sign here. And then we have 0 minus 7, which is also negative. But we got to keep in mind that we're squaring that. And when we square that, that's going to become positive. And then this last one here, we plug in a 0. And so we have 0 minus 10, which is negative. It's going to be a negative 10. And then we raise that to the fifth power. And that will still be negative because the fifth power is an odd power. So we're going to have a negative here. And that will ultimately result in, let's see here, we have a negative times a negative, which is positive, and times this positive will result in a positive number. So this interval here will be positive. Now let's go on and plug in a value in this interval here. I'm just going to choose 5. So f prime of 5 equals, so we have 5 minus 4. That's going to be positive. So we have positive. And then this middle term, 5 minus 7 is negative. But again, we have to square it. And so that will be positive. And from here on out, this middle term, let's just note, will always be positive because it is being squared. So we have positive here. And then let's see here, we have 5 minus 10, which is negative, and then we're raising that to the fifth power, which because it is an odd power, it will still be negative. So that will result in a negative value. So we have negative right here. This interval is negative. For this next one, let's plug in 8. So f prime of 8 equals, well, 8 minus 4, that's going to be positive. And again, this middle term will be positive because it's squared. And then 8 minus 10 is negative, raised to the 5th power, and that will be negative because the power is odd. So this one will have, again, a negative interval. And then for this last one, I'm just going to plug in f prime of 12. So we have 12 minus 4. That will be positive. The middle term is positive. And then, let's see, 12 minus 10, that's going to be 2. So that's a positive value. Raising to the 5th power, it will still be positive. So we have a positive here. So this interval right here will be positive. Okay, so now we have our sign chart. And from this, I'm going to actually draw a rough sketch of our function f of x by using this sign chart. And so doing that, let's draw let's see, some axes here. So x and y. And this is going to be a rough sketch of f of x given our sign chart. And so let's see, I'm going to label 4, 7, and 10. And so to the left of 4, the derivative is positive, the f of x. Remember, this is a sign chart for f prime of x. And then right now I'm drawing out f of x. So f prime of x is telling us where the slope, whether the slope is positive or negative. And so if my slope is positive to the left of 4, that means my function will be going up. And then I'm going to notice here that at 4, the derivative is 0, right? So that's why we have these values on the sign chart. So it's going to go to a 0, and then it's negative in this interval, so I know it needs to turn around. So it's going to go up, it's going to become 0 at 4, and then become negative in this interval right here. So it's negative, negative. We're going towards 7, and at 7 it's going to be 0, but then after 7 it will still be negative. So we're going to go down. We're going to go kind of like a 0 at 7 and then continue on negative. Now we're approaching 10, and at 10 the slope should be 0, but after that the slope is going to be positive. So we're going to go down, get a slope of 0, and then start going positive again. So right here is a rough sketch of our function f of x given our sign chart from f prime of x. And now we can go ahead and label some relative maximums and minimums. So it looks like right here I have a relative maximum, and that occurs at x equals 4. At x equals 7, I have neither a relative maximum nor a relative minimum. And then at x equals 10, I have a relative minimum. Okay, so now that we have this, we have everything we need to answer the initial question. So we can go back to the question. The question is asking the following. Which of the following are relative extrema of the function? We have these three options. X equals 4 is a relative maximum, x equals 7 is a relative minimum, and x equals 10 is a relative maximum. And so given this rough sketch here, we have, x equals 7 is neither a relative maximum nor minimum, so that will not be a choice. And then at x equals 4, it's a relative maximum, and then at x equals 10, it's a relative minimum. So from our options here, the only one that works out is option 1, where x equals 4 is a relative maximum. Because at x equals 10, we do not have a relative maximum, we have a relative minimum. Okay, so that was the first approach to doing this problem. I'm going to do it one other way real quick. And so let's go through that. Let's see here. Where am I going to do that? Let's do it. I'm going to write out this function f prime of x down here and do it. Okay. So we have the function again, f prime of x equals x minus 4 x minus 7 squared times x minus 10 to the 5th. Whoops. Get that to go away. Okay. Now, what I'm going to do for this method is I'm actually not going to create a sign chart. I am going to use, I'm going to determine where how the function f prime, or the derivative of the function, which is f prime of x, is behaving by looking at the end behavior and the multiplicity of the roots. So what I'm going to do is I'm going to begin, let's say, I'm going to draw out, this is going to be my f prime of x. I'm going to draw a rough sketch of f prime of x, and then from that, I'm going to draw out a rough sketch of f of x. And so for this one, what we can say is that, well, if we were to multiply this out, because all of these x's here are positive, then we know that the leading term will be positive, and it will be raised to the, well, we can imagine there's a 1 here. So we'll add up these exponents here. So 1 plus 2 plus 5 is going to be 8. So the leading term would look something like x to the 8th. So it has a positive coefficient, and it's raised to the 8th power, which is an even power. And so determining by using end behavior, we know that this function is going to kind of look like this. And now what we need to determine is, let's see if we can roughly determine how it behaves in this region. And we're going to do that by using the multiplicity of each of these roots. And so I'm going to draw out x equals 4 here. So, and this is x, and all right, f prime of x. And so 7 and 10. Okay, so what does the multiplicity of the roots tell us? Well, if the multiplicity of the root is odd, then that means that at that root we're going to cross through the x-axis. And if the multiplicity of the root is even, then we're just going to touch the x-axis but not cross. And so let's use that. So we start here, we're going down towards the 4 here, and the multiplicity is odd, so we're going to cross through this x-axis here. Then we need to come back to 7, and because the multiplicity is, it's raised to 2, that's even, so we're not going to cross through at 7, we're just going to touch and then come back down. And then at x equals 10, that is odd, the multiplicity is odd, so we're going to come back up and cross through the x-axis at 10 and go up here. So this right here is a rough sketch of our f prime of x function, and from this we can now make a rough sketch of the f of x function. So f of x, let's go ahead and make a rough sketch of that. I'm going to say x equals 4, 7, and 10. Now, looking at f prime of x, to the left of 4, we have a positive slope, positive derivative. So that means to the left of 4 on f of x, our slope is going to be positive. So we're going to be going up. And then our derivative is 0 here, so we know that the slope of the function needs to be 0. And so we're going to be 0, and it's going to be negative after 4. So that means we're actually going to turn around right here because the slope is negative. That's what this is telling us. If the derivative is negative, our slope of our function is negative. So we're going to go down. We're going down 7. Now it's going to be, because the derivative is 0 here, our slope will be 0. And then after that, we're going to continue to have a negative slope. So we're going to come down and be negative still. Then at x equals 10, our slope is 0, and then it will be positive after that. And so we're going to go and then come back around something like so. So now we have a rough sketch of our f of x function, and now we can go ahead and label it. So we have a relative max right here, x equals 4, and a relative min, make that look like an m, a relative minimum at x equals 10. And now this will allow us to go ahead and answer the original question there, which was up here. And again, we are going to get the same answer, which was the first option here, that x equals 4 is a relative maximum. All right, and that's going to wrap up that problem. And I'd like to just end the video with a little fun fact from philosophy. Did you know that in ancient Pyrrhonian skepticism, they put forward this idea that all is appearances? And from this, they conclude that what we should do is say that, things may be what they appear to be, or they may be what they appear not to be. And from this, we kind of get an opposition of appearances, which kind of creates like this a null state, which results in a suspension of judgment and a sort of tranquility of the mind.